introduction so you have as much time as possible to present.
Okay.
Hey everyone, this session is about self-de-icing LED signals. Here's a little information about it. A new type of self-de-icing LED signals were developed for highway intersections as a replacement for existing LED signal lights that remain too cold to prevent snow, sleet, and ice buildup on the lens. For 5 years, the lighting and heating performances and reliability of the new signals were tested in the laboratory and then validated using closed course tests on a building roof and field tests at multiple selected test sites of the participating state departments of transportation. The first field test site was set up in Lawrence, Kansas on a side signal head facing north. This presentation will share the results of the testing. And our speaker is Dr. Hongyi Kai. He's an associate professor in the Department of Civil, Environmental, and Architectural Engineering at KU. With expertise in lighting, he has been developing integrated solid-state lighting and heating technologies with patents and conducting R&D and implementation on those patented technologies. So Hongyi, I'm going to send it over to you.
Thank you, Lisa, for the introduction. So good morning, everybody. So nice to see you here online. So I will be presenting an R&D project we have been working in the past 5 years. So I will be so glad to share with you about the project and see if you are interested to know a little bit more about the details. This project has been collaborated with a few units, including the TRB IDEA project program, and we also got 7 states participating in this project. I do have other collaborators, including Professor Steve Shark and Eric Fitzsimmons. They're working with our team in this project. So let me go to the next slide. This project was aimed to solve a problem for the snow and the ice accumulated on the current LED signal light used on the road and on the railroad as well. You can see from the pictures here. This is problem need a lot of attention because this is really a safety issue which can cause a lot of casualties and the waste of the money and a lot of problems. So we tried to solve this problem by using some new ideas. Current solutions, let me show you the next slide. Current solutions to get rid of those snows and ice, including the manual way to brush the snows off, or spray the chemicals on this lens, or use some special devices or equipment like the snow sentry or some scoop tunnel visor. They proved working, but not in all the weather conditions. Another current solution, let me go to the next slide, is to add some additional heat generators like the GE1 shown in the picture here. Used some resistant wires to heat the lens in some increment weather conditions. They can also use infrared LEDs or any kind of additional heating devices or technologies to heat the lens. And then they need a sensor to control the heating technology to turn them off in the summer. We come out of the self-de-icing signal ideas because we know for the LEDs, they're a little bit unique and different from the traditional lighting technologies. For example, in the old days, we use the incandescent light bulbs in all the signal light. Those incandescent light bulbs, they emit the light and the heat simultaneously in the same direction. So we will get a lot of heat actually on the lens. So we don't have this problem of the snow and ice accumulated on the lens. Till we use the more energy efficient LED light. The LED actually has a lot of heat generated by themselves too. If you look at the image here, you will see we actually have 70 to 80% of the input electricity they are converted to heat, but those heat is accumulated on the back of the LED chips, so they don't emit together with the visible light in the front. So this is actually an issue in the current LED signal. You see the current LED signal. If you look at the elevation view, the side view, you will see the LED chips that are actually mounted on the back of the signal light, and the lens is on the front, right? So all the light emitted by the LED will be given to the forward direction, come to the lens, and then hit into the driver's eyes. But the heat they generated on the back of the LED chips that accumulated here and then dissipated away to the environment. Most of the heat, they are not used to heat the lens. So we think this is a waste of the energy, and we want to solve the problem. So we are come out with a new type of the signal light. It's called self-de-icing. The goal is to harvest the otherwise wasted LED heat to heat the signal lens without any additional heat generators. We also want to maintain the lens surface temperature above freezing at an ambient temperature of below like 10 degrees Fahrenheit in a very cold weather condition. We also need to adjust the power output in summer, so we don't need to waste a lot of electricity in summer, because we do not need those heat in the summer in the warm weather conditions. So that's the goals that we want to achieve. So we come out with this new signal device. You can see this is a prototype we made in our project. We have 3 colors, red, yellow, and green. This signal light used a patented technology. It's called the integrated light and heat arrangement of low-profile LED fixtures. If you take a look at closer, you will see the LEDs is mounted very close to the lens in the front. Okay, we used a gap probably only 1/4 inch, so we can have sufficient light, and then we can control the light output. Meanwhile, we can have sufficient heat accumulated on the lens. How can the heat be harvested? We used a passive heat exchanger to harvest and store the heat generated by the LEDs. And those heat will be forced go into the forward direction using another insulation layer mounted behind the passive heat exchanger. So by doing this way, the heat and the light will go to the same direction towards the front lens. Okay, we have another technology, and we did not adopt it in our current prototypes, but this technology called Type 2 can be adopted in other type of the signal light as well. For example, other types of the intersection signal light or the railroad signal light. This type of technology, we used some fibers and we used some like large LEDs, and we collected the heat directly on the heat harvest. The lens over there, and then we have the heat stored in the passive heat exchanger, and the heat will be used to heat the lens directly, and the light will actually be directed to the front direction using some fibers. We don't make prototypes based on this technology, but if we need, we can make new prototypes using this technology as well in the future. Okay. In our current prototypes, we actually used a sensor to control the power output of the signal light. You can take a look at the back of the picture here. You will see the sensor is actually connected to the driver of the LEDs, and the sensor is exposed to the ambient air. So this is a larger look, a zoom in look of the sensor. So when the ambient temperature is 4 degrees Celsius or higher, then all the red, yellow, green signal light, they will have a derated power output. We use only 32 to 26 to 32% of the power output. The yellow is a bit lower because we have a bit higher light output in the yellow signal light, so we can further decrease the power output in summer conditions. But when the ambient temperature is 4 degrees Celsius or lower, then we will turn the signal light 100% power output. So they will have full light output. When it's full light output, the signal light consumes approximately like 28 to 29 watt each, depends on different color. But when the signal light is in a derated power output, each one consumes approximately only 10 watt, very close to the existing LED signal light. Okay. We developed in total 5 generations of the signal light, and we tested in our laboratory. So we used 2 devices. One is the freezer. We put the signal light in the freezer and test all the extremely cold temperatures. We also put them in another test laboratory called the cold room. We mount the signal lights over there, and we can control the ambient temperature to any temperature close to freezing temperature or lower. So we can test the light output and the heat output. Okay. If you see this figure, you will see the signal light performance based on our laboratory test, because we power the signal light continuously without any like on and off in the laboratory. So the temperature recorded on this signal lens, including the red signal, yellow signal, and green signal, they are a little bit stable. Okay, it's not fluctuated too much. Why? Because the power is DC power continuously. So you will see from the chart, we can have the surface temperature increased by almost 30 degrees Celsius to 33 degrees Celsius above the ambient temperature, when the ambient temperature is actually close to more than minus 10 degrees Celsius. Okay, so this is a huge increase in the surface temperature. But like again, this is a continuous full power output condition, which is not realistic in our roadway situation. Okay. We also tested in a closed situation on the roof, powered by a real signal light cabinet controller. So this one, we have the signal timing to simulate the real signal timing in the road. So we tested over time, like for almost 4 years on the roof, of course, for different prototypes of the generations. This is a recorded data performance of the rooftop testing. You can see based on the signal timing, we used 90 second in a cycle. So the red signal will be on for 50 seconds, and the green signal will be on 35 seconds, and the yellow signal will be on for only 5 seconds to approximate the typical signal timing. So the red light has the highest signal, the lens surface temperature, and the green will still have enough surface temperature on the lens. But the problem will be the yellow, because the yellow, the on time is too short. So the yellow signal line is only a little bit above the ambient temperature. The ambient temperature is shown in the blue line. Okay, all right. So this is in a condition like in the cold winter condition with minus 10 degrees Celsius, that is the lowest. Another situation recorded on the roof in a warmer weather in summer. This is in August. You can see the output has been derated to only 10 watt. So the surface temperature on red signal, green signal, and the yellow signal, they're just a little bit above the ambient temperature, not very high compared to the winter conditions. Okay. We also did some field tests planned to be 5 test seats. We already have 3 of them installed. So we have Kansas installed already. We have Wisconsin installed in the field test. We also have the Michigan installed. We are still working with Maryland and New Jersey, Pennsylvania to try to install the 2 more field test sites. Let me share with you what will be the field test that we have done so far. This is the Kansas field test site we installed actually back in 2019 winter time. So it's almost 3 years over there right now. So this field test site is in the downside of Lawrence on the Iowa Street, assisted by the Lawrence Signal crew. So we have this test site ongoing right now. We collected data every day. So this is the first winter test data. You will see the ambient temperature as low as -15 degrees Celsius, and you will see the green signal light has the highest lens temperature above freezing, above 0 degree, right? But the red and the yellow is lower than that. Why? Because in that intersection, the green light has a dominant time, it's very long, and the red has a little bit short timing, and the yellow has only a few seconds. Okay, so that explains why the green has more heat on the lens, and the red and the yellow has not that much heat on the lens. Okay, and then this is a summer condition we recorded from the Lawrence test site. You will see the lens temperature is not that different compared to the winter condition, but it's still a little bit higher than the ambient temperature. Okay. Another situation for the winter, the second winter back in 2021, in January, you will see the green light has a lot of heat on the lens, which remains above almost 10 degrees Celsius, especially when this signal is under extremely low cold temperature in the early morning, with -5 to -7 degrees Celsius. And you will see the changes here, because when the ambient temperature is close to 4 degrees Celsius, then the signal will change the power output to derated power output. Then you see the green signal light does not maintain the huge difference compared to the early morning. The heat output will be reduced. So there will be some like energy saved during this process. So this is a switching performance of the sensor of the signal light. Another example, in the past winter, January 2022, you will see the ambient temperature when it's extremely cold in the early morning, the green maintained very high surface temperature. And when the surface temperature close to, the ambient temperature close to 0 degree in the daytime, and then the power output will be derated. So the lens temperature for green and red and yellow will still be not that high, but still be higher than the ambient temperature. If you take a look at the yellow here, you will see that actually the yellow light is a little bit lower than ambient. Why? Because the surface temperature on the lens is actually not affected by the signal heat itself, but also affected by the air velocity and any other conditions of the ambient. So is may caused by the big wind, the heavy wind over there on the surface temperature. Okay. A second field test was conducted in Wisconsin, in Milwaukee on the west side. You will see this is a 3 pictures we took in the field after the signal has been taken, and we installed the 5th generation in this field test site. Okay, and this is the first winter. Actually, it's not that cold back in November 2021. So you see the surface temperature for the green is above the ambient temperature, and the red is also above the ambient temperature, but the yellow is just a little bit above the ambient temperature. And if you take a look at this early morning, it's very interesting. You see the green is actually very high in terms of the surface temperature, but the red and the yellow is almost the same as ambient. It's because during the early morning from midnight till 5 or 6 o'clock, keep the green light all the time, just green light, no red and yellow during that time. And after 5 or 6 o'clock, then the signal light will come back to the normal timing. So the red will be on for a while, and the yellow will be on for a while, and the green will be on for a while. And then you see the red signal light surface temperature increased over time because the signal light get heated by the LED heat. Okay, right. And then we also tested another day under very cold ambient temperature, almost -10 degrees. You will see in the early morning, because of that signal control. So the green light has a high ambient temperature, I mean the surface temperature, and the red increased after 5 or 6 o'clock. And then the yellow from the ambient temperature almost the same to be above the ambient temperature. So this will be the changes over time. Okay. We also collected another date back in February 2022, this past winter. So under a very cold ambient temperature, almost -16 Celsius, you see the green light maintained above freezing. And then when the ambient temperature maintained close to -10 to -8 degree Celsius, the green light is still maintained the surface temperature above freezing, and the red light is close to freezing before maybe 5 o'clock in the evening, and then it dropped because ambient temperature lowered. Okay, but the yellow light maintained almost just a little bit above the ambient temperature. Okay, that's a Wisconsin situation. Another date for the past winter in Wisconsin. So it's very similar to the previous changes of the surface temperature. You will see the green light remained above freezing 0 all the time, and red maintained above 0 degree after like maybe 11 o'clock in the morning, and the yellow light is just a little bit above the ambient temperature. Okay. We also conducted another field test in Michigan in a test facilities just outside of the signal shop located in the Michigan DOT Operation Field Service Center over there. Okay. This is the first data we recorded back in November 2021. You can see the red and the green have the temperature maintained close to 10 degrees Celsius at an ambient temperature a little bit above 0 degree, right? So the signal power output is actually derated in this case because it's for this portion, you will see the difference. Before 10 o'clock, it's actually full output because the ambient temperature is close to 0. And after the ambient temperature rises above 4 degrees Celsius, then the power output will be derated. And then after 8 o'clock in the evening, then the signal will also change to full output again. Okay. Another date back in 2021 in November, when the ambient temperature maintained below 0, close to -5 to 4 degrees, the red and the green signal light maintained above 0 degree, almost 10 degree for the red, and the green will be similar, right? And the yellow light maintained just a little bit above the ambient temperature. Okay. Just in the past winter, in January, we have another date with the ambient temperature very cold in the -15 Celsius. So you will see the red and the green maintained above 0, and the yellow signal light maintained just a little bit above the the ambient. But when the ambient temperature increased, and then the difference will also be a little bit different here. And then maintained almost the same difference after 12 o'clock at noon. So this is another test date. Okay, right. Another test date back in January this year. So you will see a similar trend here with the ambient temperature close to minus 15 or lower in the early morning, when the red and the green signal light maintained close to 0 degree surface temperature on the lens. And then when the ambient temperature increased, and then the difference between the signal light lens and the ambient temperature has been maintained almost the same after noon. So this is another trend. Okay, so our plan to do next will be we try to develop the sixth generation based on the field test side. The field test will actually be ongoing for a few years. For example, the Lawrence field test site has been conducting and collecting the data for almost 3 years. We plan to have at least 2 more years data connected, so make it 5 years. And for other 2 test sites in Wisconsin and Michigan, we also plan to have them running over there for at least 5 years. For Maryland and Wisconsin, I mean Pennsylvania and New Jersey test site, we are trying to install in this year. We also plan to have them tested over there for at least 5 years. So based on the field test data, we are improving the performance, adjusting the drivers output a little bit, and also optimize some like minor issues over there. So we try to finalize the design for the products and develop the 6th generation for the actual production. We also want to use the 6th generation to get the certificate of the UL. We also want to do some initial marketing test to conduct some cost benefit analysis. And if possible, we want to team up with some like communities to have some like a field implementation in a small scale to test the signal light, see if they can be working as we expected in the following years, right? So I think that will be my presentation. I would like to take several like questions, see how can I answer them. Okay, let me share my chat.
We have a few questions. Dustin asks, does the higher temps on the green bulb have an effect on the bulb light or bulb life?
It won't affect the bulb life because the LED chips, they are well made. They have a rating of the junction temperature is lower, is 120 degrees Celsius. Then all the LED chips will be working just normally, not a problem. So the green light or any other color of the signal light, as long as the LED junction temperature is lower than 120 Celsius, which is higher than the boiling water, then we don't need to worry about the LED life. The new signal light, we plan to have a warranty for at least 5 years or even longer to match the existing signal light using on the road. Okay, we tested the thermal performance. We also tested the lighting performance over time in our laboratory. Basically, when the LED has been heated, the light output will drop a little bit, not much, because the junction temperature has increased, so the efficiency lowered a little bit. But this won't affect the lighting performance. Why? Because we have a lot of light. Actually, we worry like the signal light might be a little bit too bright. So we are trying to lower the brightness of the signal light right now using some additional controls of the optics. We don't worry about the signal lighting performance. We just worry about the heat performance. So as long as the ambient temperature is not like 120 degrees Celsius, I think it won't happen in the reality. Then we don't need to worry about the light. Okay.
So we have one question left. Our speaker on the other session is setting up, so I'll ask this. Sharon is asking if the temperature of the red LED is above ambient during the short cycle lengths in January, will the snow melt from the red lens when the temperature is below freezing?
The red signal light will not remain above the ambient temperature unless the red lights are never turned on. For example, in the Wisconsin field test site, in the early morning from midnight to maybe 5 or 6 o'clock in the morning, when only the green light is on, red and the yellow has been turned off. In that case, then the red light will maintain the same temperature as ambient temperature. So in this case, when the red light is powered, the signal light will accumulate the heat on the lens over time. So we hope to see the ice and the snows accumulated on lens will gradually be melted over time. But we did not have the conclusions there because Wisconsin is still testing those signal light. Based on our current testing in the past winter, we did not actually see any accumulation of the snow and ice on the radar signal light so far. So we will continue to collect the data, and we will be happy to update you about that.
Awesome. Thank you so much, Hong Kai, for presenting with us.
No problem.
And
My
now
pleasure.
we're off to our next session.